Hi, everyone. I'm Ivett, and hopefully you came to talk about big refactors and rewrites. Uh, just a side story to begin with. NDC was the first developer conference I ever attended in 2012. That's 13 years ago, and ever since I have talked I think at least at 50 different conferences, but never at NDC. So it's interesting. Things come full circle. So yeah, it's a special one for me. Returning to the place where I first experienced the conference. Okay, so rewrites. First question I have for you is, are you happy at work? Like, put your hands up if you're happy at work. Like, oh, that's good. Like this is much more than I usually get, because the thing is, people are engineers don't tend to be happy at work. There is a survey done by Stack Overflow, and what they found was that only 20%, 1/5 of engineers are happy. Um, the rest, there is 32% who are unhappy at work and are actively considering alternative careers, among others, goat farming. Uh, but there is also a substantial chunk of people who are like technically just meh, like not terrible but not great, and they also try to answer the question why. Why are people unhappy at work? Any guesses? Well, one of the main things is bad code quality. Um, and actually, it was the top reason. And like, who has who has a code base that is really hard to work with? Like, put your hands up if you really feel like, okay, this is a nightmare to work with. Yeah, like most people, right? And here's the interesting thing that I recently kind of started thinking about. Okay, but when I code these days with AI assistants, one of the things that I do most is refactoring, because uh, the AI tends to be really bad at generating easy to maintain code. But also, what I found is that if I refactor my code to be easy to maintain, the AI becomes much more powerful. So it turns out that one of my most important skills these days is refactoring, and particularly automated refactoring. So just keeping our code quality good. And of course, I can't, I have to take a stab at these kinds of claims. It was already a year ago when Google said that their like 25% of their code base is written by AI. I'm tend to be skeptical of these things, but specifically this one I really found really funny, because if you think about it, autocomplete can also write 25% of the lines. This is a code that was written by hand and autocomplete. These are the lines that were written by autocomplete. That's about 25%. So yeah, maybe I'm not super convinced. And there is also kind of a sorry. Yeah, this is the site. So I also want to point to another research. Now, with this research, I want to take it with a want you to take it with a pinch of salt. Why? Because it's been done by a company that is building code quality assurance software. There is some bias there, and I want you to be aware of that bias. But what they found, and there are other researches, this is the one that I like. The methodology seemed to be okay-ish. The others I could find very easy ways to debunk it. But the interesting thing is that they found that 75% of lines were rewritten within 2 weeks. There was a 39% year-on-year churn, and like 25% more duplication, and this is one that's more interesting, is 41% increase in failure rate. So these numbers are concerning, because these all kind of increased as AI assistants enter the workforce. Yeah, one more thing. You see these little QR codes there. This is more for people who are watching it from recording. For those of you here, in the Slack channel for this room, there will be a post that will have all of the links that I have in my talk. Okay, so we have a clear code quality crisis, right? Because code bases are in a horrible shape. They have always been. With the increase of AI assistance, this is just getting worse for now. So what do we do about it? And here I think there is kind of a point where people kind of want to go for like a kind of a rewrite. And here's something that Joel Spolsky said. So they did it by making the single worst strategic mistake that any software company can make. They decided to rewrite the code from scratch. And Joel Spolsky said this about Netscape losing their market share and essentially going bankrupt. Now, I need to add that Joel Spolsky was working at Microsoft, and there might have been other factors at play when it comes to Netscape's failure, for some of which Microsoft was sued. But still, there is some truth in what Joel Spolsky says there. Doing a rewrite can be really can lead to problems when it comes to a company's competitiveness. Specifically, when I was much younger, I always wanted to rewrite things, and I learned the hard way that it is actually causing problems. So we are going to talk about why that is, but there is also something I want to distinguish here, and that is a refactor or a rewrite. Refactor is the thing that you do during test-driven development. It's small, it's localized, you don't even have to tell anyone what you're doing, right? And then rewrite is when you basically re-architect the system without changing its behavior. Sometimes people use the term big refactor, which is kind of which is more of a rewrite, but like it's done in steps. I suggest mostly using rewrite for this, but the point is that this talk is about rewrites specifically. When should we rewrite? Because here's the thing, engineers do want to rewrite code from time to time, and I want to address that topic. So I'm going to start by saying why, or telling you why we consider rewrites a bad idea. This is going to be like third of the talk. We will go into a reasoning for that. After that, I will show you case studies where that completely ruin my reasoning that I will have in the first third. And these case studies are the things that changed my mind about rewrites. So for a while, I was like, never rewrite. And these case studies were the things that set me off on a trip to understanding, okay, if these successful rewrites work, after all, I need to understand what's the difference between the cases where it's not successful and the cases where it's successful. And then once I started collecting these case studies, and once I have a bunch, I found a way to make a decision on that, basically a framework for rewrites, and that's going to be the last third of the talk. So let's start with why do we consider rewrites a bad idea. Okay, so here is something interesting that Martin Fowler talks about, and that's the design stamina hypothesis. It's a hypothesis because it's not proven, but it is something that most engineers, especially more senior engineers, will find compelling as an argument. And also, like, the chart is completely just pseudoscience, but what I want to use this for is not to prove, more like the whole argument is going to be falsified in the second part, right? So it's not real science, but I want you to see the thinking process behind the people who say that we shouldn't rewrite. So we have investment over time, and we have cumulative features. The claim is that if we do no design at all, then we are going to slow down. That sounds reasonable, right? If you have a very hard to maintain code base, it's going to be slow to work on it. Alternatively, if we do good design, then at the beginning we are going to be slow because we are spending time on design. But once we got through that initial period, then we are going to speed up and we will be super fast. That's the theory, at least. Okay? So what's the problem with this? You might notice that there is a point where these two curves meet. We don't know where those two curves meet, but there is a point where they meet. And this is called design payoff line. Now, let's assume that we are a small startup. And we have a minimum viable product. Now, who knows what's a minimum viable product? Right? So this is the smallest thing that we can build in order to go to market and test that our startup is going to survive. Now, I deliberately drawn this below the design payoff line. This might not always be the case, but anecdotally, I can confirm that most of the cases, this is true. Your design payoff line is going to be above your minimum viable product. But that also has an implication, because if that's true, then when we are starting out and we want to test our product, there is a huge difference in investment risk. So as a startup, I am being responsible if I'm coding irresponsibly. Or put in a less dramatic way, it's part of our technical excellence to know when we don't need to do design and when actually getting this work done quickly has more merit than planning for maintainability. And that is why almost every successful company has a horrible legacy code base. This is the reason. Because those companies who don't have a horrible legacy code base, they didn't make it. Right? It's simple evolution. Okay. So that's interesting, because that means that there is a difference between a responsible technical debt and what Kevin Haney calls a technical neglect. So if you don't know Kevin Haney, I really recommend watching some of his talks online, because he's a work geek and goes like he renames things in software engineering in ways that make more sense. And one of these renamings that he did was calling technical debt technical neglect, because your problem isn't that you have taken on debt, it's that you neglected that debt. It's that you didn't pay it back in time. So what do we do about technical neglect? Well, the idea is that, okay, we do need to make that minimum viable product work, but after we have the minimum viable product, if the company was successful with this release, then we can start doing some work to pay off that debt. If it wasn't successful, we can just delete the code and our technical debt is gone. That's the easiest one, right? But if we were successful, that means that we can start paying back some of our debt. But how do we do that? Is that a rewrite? Maybe, maybe not. It depends. And at this point, I do want to make kind of a small distinction. Until now, I was calling these cumulative features. But in reality, what we care about is product attractiveness. What I care about is my product more interesting for people than the competition's product? And this is something I really learned at one of these Lean Poker events. So for those of you who don't know, Lean Poker is kind of a one-day coding challenge where each team has poker bots. The poker bots are playing from the first minute, like there's a starter bot that does something simple, and then every team can make changes and deploy it at any time. The point is that as the games go on, like every few seconds there is a game, the teams are either collecting points or losing. So every time that those black dots are deployments, every time I deploy something, they can see the effect. And what matters in this game isn't if you can play poker really well. Turns out it's enough if you can play poker slightly better than your competition, which might be still horrible. Okay? So what I want you to take away from this is that it doesn't matter if your product is bad. It just has to be less bad than your competition. And that's kind of the point, because here's what's going to happen. Let's suppose that we are done with our MVP and we start rewrite. The problem is that while we are doing the rewrite, that of course makes us slow down for a while. While we are doing the rewrite, the competitor is actually going to catch up with us and take over, because their product is slightly better now. So all of the users are starting to migrate over to their product. That's a problem. We are losing market share. And what's the CEO is going to do at this point? Shut down the rewrite. So, but if he shuts down the rewrite, that means that we lost all this time for nothing. Now we are back at square one. We started a rewrite, our code is still horrible, we slowed down, and now we are even behind the competition. That's horrible news. So that's why people say, never rewrite. But here's the thing. In this argument, there were two implicit assumptions. And I'm going to start talking about the case studies. And what I want you to think about while I'm talking about the case studies, what are the two implicit assumptions that I made in this argument, this flowed argument, that are not true for these case studies? For none of them. There are two such implicit assumptions, and I'm going to tell you at the end, but try to figure it out yourself. So let's move on to the case studies. First story is one that I really like, because it has to do with Flash, Adobe Flash. Who remembers Flash? Okay, a lot of people, actually. I expected less. Of course, Flash was discontinued, right? And there is a company who is making a presentation software, and they built their entire product on Flash. That's bad news for them, right? Because now they don't have a platform to run on, and they need to somehow find a way out of it. Turns out that this company tried a few things. First, what they tried to do is write a compiler from Flash to HTML5 JavaScript. That didn't work. Then they tried to write one from Flash to C++, then JavaScript. Didn't work. Then they tried a bunch of other things, including just trying to re-implement the same thing in JavaScript. Didn't work. In the end, what they did was at some point, they decided, okay, it's fine. It's not going to be the same product. We are going to build a better product. But at first, it's not going to be better. At first, it's going to just have the simplest functionality that a business needs. Because here's the thing. Adobe Flash were running on consumer PCs for much longer than on business PCs. Like, companies banned Flash much sooner. So business users, their actual paying customers, were most at risk. So what they did is they built the minimum feature set that a business needs and released it as a separate product aimed at businesses. And they actually asked for a higher price. That was a really, like, they had a worse product at first, but they were charging more because it was for businesses. And then they code up. Eventually, they re-implemented most of the things. They couldn't migrate between the two automatically, but they figured it out. And today, they have just one new product that works for everyone, and it's in JavaScript. So that's the first story. The second story is the catastrophic failure, and this is a very personal story for me because this is something that I was personally involved in. And there is a YouTube video that details this story more, and that's the link there. But the story is this: we had a monolithic system that was kind of like email marketing system, okay? And we had this tool that, like, if you know Zapier or N8N or Make, some of these no-code tools where you can just create a workflow. Now, we had that built into our system. But while it was a monolith, it was easy because every one of these boxes could just call local functions. But then we started to, like, we had a monolith, so we wanted to make things better, and we started to introduce microservices. And also we wanted to make sure that other companies can build plugins for this workflow engine. So we needed a way to actually call outside, and well, the way the system was built actually result in unhandled errors that really caused horrible problems. And then what we realized is that the way we were calling outside and the way we were handling these little boxes was fundamentally flawed. And we had to remake every single one of these boxes. So what we did, we simply looked at the most problematic cases, we fixed those first, and one by one we replaced every single one of these boxes until our old code was gone. But during this period, I was waking up to PagerDuty every other night because we had a ton of these errors, unfortunately. So this was also an interesting one where we basically just took these boxes one by one and re-implemented them. Another personal story is that of an import. So this import was importing CSV files of our customers, and it was then loaded into their customer database. Problem was this. This was meant to be a daily import. For one of the customers, the daily import took 25 hours. That doesn't sound like a daily import. There is one day in the year when it worked. Who can guess what it was? What it was? Sorry?
It was January.
Sorry?
End of the year, beginning of the year.
No, it was. No. It's like the 25 hours in a day. Daylight saving. Yeah, exactly. Daylight savings time change. That was the only day when it worked. So we needed to fix that. And here is the thing. Like, it was taking that CSV file and reading it field by field. And for every field, it was generating a SQL query, running the SQL query, and then going on to the next field. This meant round trips between the server and the database for every single field. That's very inefficient. Problem was that this import had lots of settings, and our customers could customize it in any way. So what we couldn't do is just replace it with a single query. But what we could do is replace it for this customer with a single query. Like this one customer that had 25 hours, we wrote one query that could handle that specific case. Okay? Can you guess how long that take? How long the query took to do the same job that the 25-hour import did? 5 seconds. Like, that's a huge difference, right? So what did we do? I mean, that's not great, right? Because now we have an if user ID equals user ID in the code. We don't want to keep that there. How do we fix this? Well, what we did was okay, now this works for this customer. Are there any other customers that have the same settings? Yes, there were. Okay, so every customer that has these settings are going through this new import. Great. How many customers do we have left? Well, a lot. Okay. What features do we need to implement for which customers? We created kind of this map of which feature, like we could, at any point we could tell which feature, if you implement that, would enable the most new customers. Okay? And then what we did, we had like this, in the middle we had like a router that could tell, okay, is this configuration setting handled with the new import? If yes, we just ran it with the new import. If no, then we ran it with the old import. Took us about half a year, but we replaced almost all of the old import. We had a couple of exotic cases and about 10 customers who were still using the old import. At that point, we just stopped and waited until those 10 customers churned. But in the end, we could delete the old import. Okay. Another interesting story. This is a company that had a kind of service that like where they wanted to enable like outside collaborators to build plugins for their service, like build they wanted to become a platform essentially. And their problem was that when they told the engineers that, hey, we are already using microservices, how about we just expose the APIs of our core system that our microservices use? The engineers freaked out. Like, are you crazy? Like this? Like, no one is going to understand this API. It's just haphazardly put together. We need to refactor it before we release it. Okay. Now how do we do that? Well, the way we did that is we basically looked at which are the most useful API endpoints that we would implement. And then we did two things at the same time. One, we implemented the new API endpoints for every single use case. But as we were implementing that, we were immediately refactoring the microservices to use this new API. Why? Because we didn't want to maintain two APIs long term. And the other reason was dog fooding. We wanted to find out if it is actually useful as an API. So we kind of migrated over our existing microservices to these new APIs. Okay. Next case study. Who uses VS Code? Lots of people. So the interesting story about VS Code is that Microsoft already had an IDE. It was called Visual Studio. Who is using Visual Studio? Actually a lot of people. Okay. But they had a problem. Web developers hated Microsoft at the time. Absolutely hated them. I was one of those developers, and they wanted to kind of convince or lure the web developers towards themselves. And they came up with this idea of re-implementing a really simple, streamlined IDE called VS Code using Node.js with the libraries that were already there. And it worked out pretty well. It became a very widely used IDE, and I would say that web developers don't hate Microsoft anymore, which is a big win for Microsoft. So that was interesting, but the key here that I want you to notice is that they didn't implement the whole of Visual Studio. No, they created a new product that was addressing a new market, right? They didn't try to convert everyone to VS Code, and as you can see, there were actually a lot of people in this room who are using Visual Studio. Having said that, I'm surprised because at most conferences, like 2 hands go up. So yeah, last example. This is actually my own product, my business's product, and the way I started that business is I had an idea for a hobby project. I started building it. I hacked it together, and then I organized. This is actually the Limpoker events, and I organized the first event. And when I still didn't finish the platform, and then like 3 days before the event, I realized that I haven't written a single line for the front end. I just had the back end, and I was like, okay, I need to find something out. So I basically built a single 5,000 line code in 3 days that was like write once and forget it. Like after that, I couldn't really modify it because it was so messy. But it did get the job done. But of course, eventually I wanted to get rid of it, mostly because until I re-implemented the front end, people had to refresh manually to see new data. And that kind of broke the experience, right? Now I have a beautiful React front end. But how did I do that? Actually, I don't have a beautiful React front end. I just have one single page that has reactive elements, and that is re-implemented. The rest of the front end is still the old front end because it works. But I replaced that one part because I couldn't implement the functionality with the old one. Okay, so these are the case studies that I wanted to show you. Let me check on time. Okay, I'm still good. So let's talk about the takeaways. Because what I started out with is that we have implicit assumptions here. And then I shown you all of these examples. Now I'm curious if anyone can give me ideas on what those assumptions were. What was different about these than the reasoning that I gave you at the beginning? Any ideas? Yeah. That was one of the things that some of them, like you didn't have an option but to rewrite. Yeah, that's like you needed to extend the product. You needed to rewrite. Yeah, any other ideas?
Competitor will do better. Competitor.
Sorry.
Competitor will do better.
Yeah, but in this case, like you mean okay? So you said that the competitor would do better. That was something that was a consequence of our assumptions. Like we, yeah, yes. Oh, that's also an interesting. Yeah, that could be that the competition has no technical depth. I would say yes, that might be an assumption there, but I would say that even if the competition has technical depth, the reasoning would still work. Okay, so I'm gonna tell you the two reasons. First reason, during the rewrite, we don't deliver value to the business, and this is the first one that you mentioned. So good job. What was different about all of these cases is that we didn't do a rewrite for the sake of the rewrite. We did a rewrite to implement a new feature or to get it off a platform that we needed to get off, right? So that was a very important point there. The other important point is that the rewrite is an all or nothing project. That was also kind of the argument there because, like I said, if you remember back, I said, like, the rewrites get shut down and we are back at square one. This is not necessarily true because if I make the rewrite in a way that even during the rewrite I'm improving on the code, and even during the rewrite I'm already having advantages of that rewrite, then this is not true. Okay, so these are the assumptions, and then how do we sell? Actually, it should say rewrite, not refactor. Sorry. So how do we sell this whole idea to the business? And the trick is that you don't sell it to the business. You don't tell the business that you are doing a rewrite, because you shouldn't be doing a rewrite. You should be implementing features, and the way, like, that should be the implementation detail, that you are implementing that feature by rewriting parts of the system. Okay, this is a very important point. You can actually, if you have a more technical leadership that understands this, it is okay to tell them, and it's okay to be open about it. If they probably wouldn't understand anyway, it's probably no point in telling them. But basically, what I want you to understand is that we need to keep delivering value. And there is a way to keep delivering value while doing a rewrite. Indeed, in some cases, doing a rewrite is the faster way to deliver that value, and we should be taking advantage of that. And this basically comes back to the first principle of the Agile Manifesto. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Uh, Everyone just remembers the first page of the manifesto. This is below the fold. There are 12 principles. This is the first one. And I think this is the most important one. So much so that it is basically, if you go on my LinkedIn page, on the at the top, the banner, I have that quote in there. This is the one quote I live by. And basically, when we do rewrites like this, we ensure that we are still prioritizing value of valuable software, and also also justifies the rewrite, right? Because if you rewrite just for the sake of the rewrite, then you don't really know which parts are important to rewrite. You don't really know what would be a better design because you don't see the future. But in this case, you don't need to see the future. You know what you need to implement, and then you know what structure fits better to implement it. So going back to our original case studies, I basically want to show you two or explain two main ways you can do this kind of rewrite. The one solution is creating your own competition. So this is the case of the Flash, like getting off of Flash, right? They had a product that they created a new product for a different market, and that was their own competition in-house. With VS Code, they had Visual Studio, but now they had another IDE. With my product, Limpoker, I had a front end, but now I have a better front end for certain very specific use cases. Not for the entire front end, but for one use case, I simply created competition. You can switch to the old front end, by the way. There is a button there for people if they want to switch back. But at this point, there's no need to. Okay, so this is the first strategy. If you ever feel like you are use this strategy when your product manager comes to you with different product ideas, and you keep giving your product manager like really big estimates, and he or she just walks away sad every time. Because that means that your big estimates are a clue that your code base is not built in a way that enables these true requirements. And that's a point where you can think about, okay, dear product manager, what would you think about us building a new product for a separate market and getting out of this cycle of you going away? So this is actually a really great conversation to have with a product manager, because you're not telling them, hey, we can't do this either. You're telling them, okay, I noticed that recently we often gave you large estimates, and the reason is that we have this bad code base. How about we try and find a set of features that address the market that you are trying to solve now, and let's build a new product for them. The next strategy is incremental replace with user value. And these are more useful for backend stuff. So you have high failure rates. You have performance issues. These are the stuff where you can use this strategy. Because in this case, you're not going to add new functionality. You are not going to release something new into the wild. You are just going to make sure that your system in the backend works well. And the way you do that is you try and find small use cases where you can improve, and sometimes you actually need to keep the two systems running in parallel, but you're going to incrementally replace the old system with a new system. This is also called the strangling fig pattern. There are these in the rainforest, there are these strangling figs that first grow on the top of trees because they don't have enough light down there. They grow on the top of the tree and they start growing downwards, and they slowly strangle the tree that's inside. And then in the end, you end up with these strangling fig trees, and you can still see the tree inside, well, the place of the tree inside, because the tree inside dies and disappears. But that's kind of the strategy that you can use there. Okay, so now you have two specific strategies to do these kinds of rewrite. But there might be others, and I also, when I first gave this talk, that was the end of the talk. And then I got a question from the audience that was pure genius. So I had to add the answer to that question. The question was that I mentioned two criteria, right? One criteria was that the rewrite has to add user value, and the other criteria was that it has to be incremental. And the audience member asked, what about the cases where you only have one or the other? Is that a viable rewrite? Or do we need to have both? And then I thought a bit about it, and actually, at the same conference, there was a talk that convinced me that one of those quadrants is actually useful. So we have the two options, or the two criteria, and then what I want to do is on one axis we have the customer value, on the other on the incremental delivery, and then I want to figure out what's with all these cases. So what I told you at the beginning, I think that's true. That's true that if you have no customer value and your project is all or nothing, you're almost definitely going to fail with your rewrite, because you are going to fall behind your competition, and the CEO will be justified in shutting down the rewrite. I also talked about this other corner when it's usually successful. You can actually do rewrites like that. Now, how about no customer value and incremental delivery? And my gut reaction would have been, no, that's not going to work. But then I saw a case study by Shopify. It was a talk by Kristen Weststeinde. I should have included that link. And she's working at Spotify. And what they did was they created a dashboard, a leaderboard for teams that showed how far they are with migrating to the new structure. Like, they had an old structure and they wanted to introduce a new structure, so they migrated over one by one. That was incremental, and they had a clear motivation for the teams because they wanted to win the race, to be the first team to replace all of the old structures. Okay? So that can work. I would say it's more challenging than if you actually have customer value, and I encourage you to aim for that option. And then all or nothing and clear customer value, I would say that's probably going to fail. I haven't seen a case study where it worked. The reason I think is the same as with startups. Like, you basically at this point you have a customer value, but you are acting as a startup that is trying to build a huge big MVP, right? It's probably going to fail, so I would recommend not to do that. And then a few words on coding assistance. So another question I got from another audience was, okay, Ivett, but how about coding assistance? Surely it is much easier to write code with coding assistance. And that's true. I would say that's true. But you need to be very careful, because it's not enough for you to actually translate the code from one to the other. I actually partially did that with the front-end rewrite that I mentioned. And the thing with that is the AI is going to generate code that is almost as bad as the original. And you need to still refactor it. So you need to be very conscious about doing this rewrite in in a responsible way where you're actually improving on the design. I would say that probably you can, like, in general, I don't think that AI assistants are giving that much of a productivity boost. I would say it's probably about 30 to 40% that we are working faster with them. But with specifically rewrites, this might be a much higher number because we already have all of the functionality, so we just need to kind of translate from one to the other, but still you need to be very careful with the refactoring. So I would say that right now we are in a historic moment where we can do rewrites faster, and we haven't created that much legacy with AI that it's again infeasible. Because my guess is that the AI generated, like we are going to build much more things with AI, and it's not going to be better quality. It's more like going to be even more AI slop. But that's of course an opinion on my part, and not everyone might agree. Okay. 2 quick plugs at the end. One plug, I have a YouTube channel, and I need one more subscriber to hit 14K. So whoever is among you subscribes, thank you. And I also have a group coaching program. If you enjoyed this talk, I give lots of talks, and I teach people how to give talks, specifically technical talks. So if you are thinking, oh, I don't know, I don't like to be on stage, or it sounds scary, or I just want someone to give me feedback on my talk, it's 40 euros a month, really cheap. So sign up. It's a good opportunity to get better at speaking. And honestly, speaking engagements got me a lot of jobs. So, and then just my personal website. And yeah, I guess that's it. Do we have any questions or time for questions? Yeah, we have a bit of time for questions. Any questions? Maybe some other genius question I can add to the next talk, yeah?
What if there is no customer value in rewrites, but there is developer experience value?
Yes, that was a Shopify case. So I think that's if you can actually make sure that there is a developer experience improvement, and you can quantify that, make it clear, motivate your teams towards it, good. Just make sure that it's incremental. Any other questions? Oh, yeah. If there is no competition, have you ever seen a company that doesn't have a competition? Okay. Well, if you don't have a competition, genuinely don't have a competition, maybe, I don't know. But if you don't have a competition, likely you will soon have. Yeah. Okay. By the way, if you see me walking around aimlessly, I'm horrible at initiating conversations. Okay. So I usually hide in the corner or just walk around aimlessly. Feel free to talk to me. Actually, I ask you to talk to me because it's much more fun to get to know people. Okay. I guess thank you for your attention, Dan.